Warning: tube amplifiers have lethal voltages inside them. Please do not attempt to build, test, or repair these without understanding and following all safety protocols. Hey y'all! Well, we're ready to start knocking out this KT120 monoblock, and we're going to do a little bit different step-by-step build process on this video. Because this chassis is kind of narrow and cramped, I really couldn't figure out a way to get like the camera angle and then also get both hands in there with the soldering iron and stuff. And so what I'm going to do is I'm going to explain, like, here's what we need to do first, and then I'm going to do that part of the build, and then come back and show you what that looks like, you know, where all the wires go and everything, and here's what we need to do next, and go step by step through like that, and try to make sure that I do things in an order where, like, you can see everything clearly. And then near the end of this video, I'm going to walk through the schematic and say, here's what we've done, and here's where everything is in the schematic in relation to the work we just did. And also show you, like, here's where you need to stop, power the amp up, make sure everything's working right before you go through. The worst thing you can do is, like, just, you know, build the whole thing and then plug it in and hope it works. You need to be testing it as you go along. In case there is a problem, you know that, okay, it happened in these 5 wires I hooked up, and not like where in this whole thing is messed up that's making it blow the fuse or whatever happens. So anyway, let's get to building this thing. Okay, first thing you do after you bolt in the IEC socket is we install this ground lug for the chassis. So first you have the button head screw with a K-nut, which is one of these guys that's got the washer built onto it, the little star washer. Then you put the ground lug, then you put another nut on it so it's double nutted. And then you have the ground wire that comes up and over here to our ground connector on the IEC socket. So let me show you what I've done so far on the grounding layout in the amp. Like I showed you before, this is going to be our star ground point. These 2 tags are tied together with this little ground strap. We have the center tap for both the high voltage AC and the center tap of the 6.3 volt heaters hooked to our star ground point. And then each one of these tag strips, like this is the part that's attached to the chassis, we're running an individual ground wire from each one of these center points over here to our star ground point. So there's a ground wire from this terminal to here, from this terminal to here, and then from this center terminal to here. So we've got all those connected up, and then we've got the 2 big caps bolted down, and we're going to start by finishing up the power supply, or at least the secondary windings. And so we're going to take these 2 6.3 volt heater wires, and we're going to put them into the lower hole on these 2 tags right here. It's AC, so there's no polarity. Then we're going to take these 2 red wires, and they're going to go to these 2 terminals on the rectifier tube. And then this is pin 8. So it goes 2, 4, 6, 8. So 4 and 6 are going to go to the high voltage. Then 2 and 8 are the heaters. So we're going to bring these 2 5 volt wires and connect them to these 2 terminals. And this will be where we pull the high voltage off of the rectifier tube. And then the last thing I'm going to do here in this little bundle of stuff is we're going to take these 2 wires, which we're wiring this up for 120 volts. If you're in another country, you need to look on the Hammond website. The link's below, and it shows you all the various color codes and how you hook the wiring up on the primary to suit your country. But if you're doing 120 volts, it'll be the white and the brown. And we're going to connect them to the unfused side of the IC connector, or the neutral, right there. And then these will curve up and go like that. And then these two will eventually connect to one side of the wire that goes up to our switch and then comes back to the hot terminal, or the fused one, on the IC connector. So I'm going to go ahead and hook these secondary wires up. Oh, and then one last thing we're going to do is this purple wire, which is the 50 volt tap off the transformer. It's going to get connected into this lower hole of this tag on the far end here. So let me get all those soldered up and I'll show you what that looks like. So we got this first part of the power supply wiring done, which is the secondary leads of the power transformer. And this really neatens up the inside of the amp. We got the heaters soldered here to the bottom terminal of these two points of that tag strip. 50 volt tap that goes there. Again, this is the grounds for the center tap of the 800 volts and the 6.3 volts. 5 volt heaters go to these two pins, 2 and 8. 4 and 6 are the high voltage. There, you can see they're up underneath the yellow one. And then here in the back we have the primary white and brown, which is for 120 volts, hooked up to the neutral on the IEC connector. So the next thing we're going to do is start installing the heater wiring. So we're going to use a pair of 18 gauge solid core wires twisted together. We're going to start from here. It's going to come over, go down this little channel here. I'm just going to come over here to the heater pins on the KT120. Then it's going to come back, go up, over. It's going to go across the front here, and then come up and go to these two pins on the driver tube. As you can see, we're running the heater around the perimeter here, away from all the signal wiring or any part of the wiring that's involved with the audio. And we're going to use wire that's twisted up like this. And this is kind of just a crude start to it. It's going to come over, go like that. And like I said, it'll jump back over and across and around. So I'm going to go ahead and make up this heater wiring and get that soldered in place. And I'm also going to go ahead and start on a similar pair of twisted 18 gauge wires that are going to run across the underside of this channel up here to the power switch and back to the IEC socket. And then we'll have these two wires off the primary go to that. And we will have the transformer all wired up. So let me get that done and come back and show you what that looks like. Okay, so I got the heater wiring installed, and we started back here with the 18 gauge solid core wire that we twisted together. Runs up here, comes up here to the heaters for the KT120. Then it comes back off this daisy chained up, runs across here, runs across the front of the amp, comes up and over to the heater pins on the 6EJ7 9-pin tube driver. So these two wires here are coming off the switch, that they go over to the bridge rectifier that we're going to install here later. And then a little cap and a dropping resistor, and that's our illumination or indicator light on the power switch. You can see these two wires here. They're connected to another pair of twisted 18 gauge wires that run on the underside of this channel, and then come over here to the, one of them is on the fused side of the IAC connector, and then the other one goes to the other two wires going to the transformer primary. And I can't really show you how this wire looks because I'd have to take the top panel off, and I can't take it off because the transformers are in. So anyway, it's kind of tucked in here And you can see the two ends of it. And this will be the first time that you want to power up the amp. So you want to hook up your power cord, turn the power switch on, and check for AC voltages on 3 different spots. On the 6.3 winding, unloaded, you're probably going to see around 6.7 volts. Over here on the 5 volt, you're going to see about 5.7 volts AC. And then on the high voltage, and be super careful, guys. If you need to use alligator clips on here to feel safe checking those voltages, use alligator clips. Got a whole series about safety, and I'm not going to go into that too much, but guys, this voltage will kill you. So, having said that, you're going to see about 870 volts unloaded across these 2 terminals. Then over here, you're going to see your 6.7 volts again. Same thing over here. With no tubes in the sockets, that's what you're going to see. I can't stress enough to test as you go along. Every time you kind of finish a few items, you want to power it up and make sure that it's not blowing a fuse or that there's some other issue, because right now this is really easy to diagnose. If you hook up the power cord, you turn the power on and you've got no voltage or it blows a fuse, there's not a lot of stuff hooked up for you to try to trace back and figure out what you've done wrong. Or if you've got crazy voltages somewhere, you might have hooked up the wrong wire to the ground here. The center taps you might have gotten wrong or something. So this is the time you want to check this stuff. But this all came out good. So the next thing I want to do is I'm going to go ahead and wire up the bridge rectifier, and then we're going to put the smoothing cap for the DC. We're going to put the drop-in resistor probably on the positive lead, although it doesn't matter, but the positive lead's a little shorter, so whichever one you might need to add a little length to is the one you can put the resistor on. And then get the indicator light wired up. And then the next thing I'm going to do is I'm going to wire up this first cap. And it's going to be grounded here. It's going to sit in there like this. This lead on the cap is going to get a wire soldered to it with some heat shrink tubing. Going to bring it around, and it's going to come over here to pin 8 on the rectifier tube. And then I'm going to pull these 2 wires from the choke that's on the top side. I'm going to connect one of them to this pin 8. Then the other side of it is going to connect to the positive side of this second cap. And then we're going to run a wire from here over to our star ground point. And I'm going to show you what all of that looks like. Before I wire up the second choke in this third cap, we're going to power it back up with a rectifier tube in it. And we're going to check and make sure that we've got our high voltage DC on the second cap, and make sure that no fuses blow, and also make sure that this stuff's wired up. I might even power it up after I wire up this bridge rectifier, and just make sure that the indicator light works before I start wiring up this cap in this first choke. So let me get some of that done, and I'll come back and show you what that looks like. So we got the first 2 caps of the power supply wired in. One side of this film cap comes over here to our star ground point, which is these 2 terminals on this tag strip. So on the other side of this cap, this wire comes around and over here to pin 8, which is the DC high voltage output of the rectifier tube. And we also have one wire from the top mounted choke that comes over to this same pin 8, goes through the choke, comes out, and hooks up to the positive side of this second cap. And then the negative side of this cap comes over here to our star ground point. And also went ahead and wired up this little bridge rectifier that I use for the LED illumination on the Angel Eye power switch and hooks up here to the 6.3 volt connection of the driver tube. You'll see there's a couple little squigglies that indicate the AC side, and then there's a positive and a negative. Negative side obviously gets hooked up to this black wire. The positive wire goes through a 3.3K resistor, and the value of this resistor can be adjusted to taste on how bright you want the illumination of the Angel Eye power switch or whatever other kind of indicator LED you might want to use. So that completes this little circuit and the indicator light. So at this point, we're ready to do our second power up. Just for safety's sake, we're going to use alligator clips for both connections. So we hooked up to our star ground point and the positive side of this cap. Power up the amp. LED should come on the indicator light, and then you're going to see somewhere around 600 volts at this terminal, which is one of the reasons that I went with 600 volt caps for all the caps in this amp, in case this amp gets powered up without the power tube in, or even on initial startup, because the voltage is going to go up fairly high until this tube starts conducting. And so again, on this power up, you should see 600 to 605 volts or so on this terminal. And at this point, there's no bleeder resistor installed. So once you're done with this test, or wait to do this test until you can let the amp sit for quite a while for the voltage to drain out of these caps. And go ahead and leave the meter hooked up, as the resistance in your meter will help drain the voltage out of the circuit. And obviously don't go in here poking around until you can verify that there's no voltage left on this cap. So the next thing we're going to do is we're going to install the bias circuitry over here on this tag strip before we put this second choke in and kind of crowd this area up with that. It's a lot easier to do that now. So we're going to put diode from here to here. We're going to put the filtering cap from here to here, this little area. Then we're going to run the power wire from here up to this tag strip where the rest of the bias supply is going to go. And I'm going to get this wired up and then come back and show you what that looks like. Okay, this is the start of our bias supply wiring. 50 volt tap comes back here to this tag strip. We put the diode across here with the stripe facing the tap. Then on this side we have the cap that goes between here and the ground. And remember, we have this connected via this wire up to our star ground point. Here's the negative of our bias supply that comes up here on this red wire to this terminal on the tag strip. And from this point, we can wire up the bias pot and the other resistor and filter capacitor. So now that we've got this done, we can go ahead and bolt the second choke back here to the back of the amplifier and get that wired up and finish up our power supply. Okay, so let's go over what we've already wired up. We've connected the ground from the IEC connector to the chassis. The fuse is built into the IEC connector. We've taken the fuse side of that connector to the switch, then to the primary windings, and then back to the neutral. So we've completed the primary circuit. We've hooked the high voltage leads off the secondary to pins 4 and 6 on the rectifier tube. We've hooked the 5 volt winding up to pins 2 and 8 on the rectifier tube, and then pin 8 is where we pull the high voltage DC. We've run that to the first cap with the other side of the cap going to the star ground point. Then we also wired one side of the top mounted choke to this same pin 8. The other side of the choke goes to the positive of this 100 UF 600 volt cap, and then the ground side goes to our star ground point. What we haven't connected yet is this second choke, the second cap, or run the wire out of the power supply section up to the front of the amplifier. Okay, we've done the 6.3 volt wiring. We've run those to the tube filaments. And then we also have hooked the center tap of the 6.3 volt winding to our star ground point. So what we're working on now is this bias supply wiring. We've got the 50 volt tap that comes over, goes through this diode, and the 100 volt, 100 UF cap. These are both in the tag strip in the back of the amp. And then this is to ground. We've run this wire up to the middle tag strip, and we're fixing to install these components and run this adjustable bias point up to the front tag strip. So that's where we're at right now. Let's get to wiring this stuff up, get this choke and this other cap wired up, and then we'll be finished with the power supply schematic part of this build. So this red wire here is the negative voltage going to the grid from our power supply. The white is the wiper, the black is the ground. And these three wires are kind of backwards from what we think. This red wire is negative voltage. So the ground would be positive in relation to that. So here we've got a 100K safety resistor that goes from the wiper to the negative. So if the wiper goes open, this negative voltage goes to the grid and keeps the tube from red plating, basically just turning the tube off. Without this, if the wiper went open or this white wire went open, the tube would go wide open and red plate and start burning up stuff and bad stuff happening. So this next one we have is what I call the dummy resistor, which is a 10K resistor that goes between the ground and the actual potentiometer, so that no matter how far down you turn the pot, you can never go below about 35 negative volts on the grid, which also keeps the tube from red plating and tearing up stuff. So it's another kind of fail-safe thing. So between this safety resistor, which keeps the tube from ever losing its bias, and then this other one, it'll keep the voltage between 35 and 70 volts no matter where you have it turned, and it allows you to adjust the bias to control the operating point of the tube. And then we're going to have a grid leak resistor between here and this terminal, and then this is going to go over to the grid with the grid stopper. The last thing we did is we've installed the choke. One of the wires from the choke goes to the positive terminal of this first cap, goes to the choke, comes back out, goes to the positive of our third filter cap, and then here we have the ground for this cap that comes over here and goes over to our star ground point. So we got, the cap's all grounded now. This is the positive lead that comes up here and goes to this terminal on the tag strip. And then here we have a 470K bleeder resistor that goes between the positive and the ground to bleed off the voltage when you turn the amp off if there's no output tube in it. And then even if there is, it gets the last little bit of voltage out. And I feel like these help stabilize the power supply as well. You can use a lower value here, but realize that you quickly get into dissipating a lot of wattage and heat. Even using this 470K, we end up with Ohm's law. We got 600 volts across it. That's 3/4 of a watt. We're using a 2-watt resistor, which is fine. But if you went with like a 300K or a 220K, you're going to have to put a lot bigger resistor wattage-wise, and you're going to be creating a lot more heat, and you're going to be putting more load on the power transformer. But the main thing is I don't want a really hot running resistor inside the chassis, so I think a 470 is a good compromise. So I did power this thing up again, and again we used alligator clips. We put one there, put one over here on the ground, powered it up, and unloaded, we're seeing 600 volts at this terminal, which again is why I wanted to use 600 volt caps. And then shut it down, let this voltage bleed off, and it took about 5 minutes. Then I came in and checked this voltage, turned the amp on its side so I could get to the bias pot, turn the amp back on, and you should be able to get a range of negative 35 volts to negative 70 volts, turning the pot back and forth at this terminal here that's going to be our negative bias on the grid. So if all that checks out, we're ready to move forward, and we've got the power supply finished, and this looks like a great place to end this video. Well, I hope that build sequence made sense, and that the schematic made sense to the work we were doing, and that you're enjoying watching this type of a build step-by-step process. I know some of you folks really like watching, the actual work and the soldering and stuff, but I've done a lot of those kind of videos and I just couldn't figure out a way to get the camera angles to work on this one, so I think this will work fine. We've got one more video to do, and I know that sounds crazy, but we're really like 80% of the way done. We've done all the hard work. And I know there's like a whole nother schematic to go, but I'm telling you, that part goes quick. And so, again, I think one more video, and we'll have this thing ready to hook up to the analyzer suite and see if it compares to the other one good. If it does, I do want to put them both on the scope, do a little bit of work there, but we'll get into that on the video after this. So anyway, if you're enjoying this series, please subscribe to the channel. Please like the video. Thank you, Patreon folks, and also people that make donations to my website. It helps me be able to build stuff like this for you guys for the channel. So until next time, have a nice day.